Building your own processing script in PyQGIS. Hello guys. In this session, you will explore how to write a custom processing script in PyQGIS. PyQGIS is the Python API for QGIS, which allows you to automate tasks, create custom tools, and extend the functionality of QGIS. By the end of this session, you will have a solid understanding of how to create, customize, and use processing scripts in QGIS. Introduction to processing scripts. Processing scripts are a specific type of PyQGIS script that can be integrated into the QGIS processing toolbox, making them accessible to other users. Why use processing scripts? First, automation. Automate repetitive tasks to save time and reduce errors. Customization. Create custom tools tailored to your specific needs. Integration. Seamlessly integrate your scripts into the QGIS processing toolbox. Reproducibility. Share your scripts with others to ensure consistent results. Common tasks automatable with PyQGIS. Here are some common tasks that can be automated using PyQGIS. First, data conversion. Convert data between different formats, for example, shapefile to GeoJSON. Spatial analysis. Perform spatial operations such as buffer, intersection, and clipping. Map creation. Automate the creation of maps with predefined styles and layouts. Data processing. Clean and process data, such as removing duplicates or calculating new fields. And batch processing. Apply the same operation to multiple datasets. Step-by-step guide to writing a processing script. Step 1. Open QGIS and access the processing toolbox. Open QGIS. Click on Processing in the menu toolbar. Select Toolbox to open the processing toolbox. Or Ctrl-Alt-T. Ctrl-Alt-T. Step 2. Create a new script. In the processing toolbox, click on Scripts. You can choose Create New Script or Create New Script from Template. A new script editor will open with a basic template. Step 3. Customize the script. Edit the template to suit your needs. You can edit Python code to automate tasks such as loading data, performing spatial analysis, and exporting maps. After that, save your script with a meaningful name. The example script. Below an example of a custom processing script in PyQGIS. This script takes an input vector layer, counts the total number of features, and adds the count as a new attribute to each feature in the output layer. Let's break this down step by step. Import necessary modules. From QGIS.pyqt.qtcore import qcore application. From QGIS.core import QGIS processing, QGIS feature sinks, and others. From QGIS.pyqt.q tcore, import QVariant. QGIS Processing core class for creating processing algorithm. QGIS feature sync used to write output features. QGIS processing exception handles errors during processing. QGIS processing algorithm base class for custom processing algorithms. QGIS processing parameters feature source defines input parameters for vector layers. QGIS processing parameter feature sync defines output parameters for vector layers. QGIS field and QGIS fields used to manage attribute fields. QGIS feature represents a single feature in a vector layer. QVariant specifies the data type for the new attribute. Class definition. The count feature algorithm class inherits from QGIS processing algorithm and defines the behavior of the script. The class structure. It includes input and output. Input and output are internal IDs like variable names for parameters. Then define tr self, string return tcore application dot translate processing, string. Define create instance self, return count features algorithm. Name of the algorithm as it appears in the toolbox. Define name self, return count features. Display name of the algorithm. Define display name self, return self.tr count features. Group name of the algorithm. Div group self, return self.tr custom scripts, or you can use your name, for example, my name as scripts. Group ID of the algorithm. Define group ID, return custom scripts. Short description of the algorithm. Define short helps string, return self.tr counts the total number of features in a vector layer and adds the count as a new attribute. Initialize the algorithm. Div init algorithm self config equal none. Added input parameters for the input layer. Self.add parameter. QGIS processing parameter feature source. Self input self.tr input layer. QGIS processing dot type vector any geometry. Then added output parameter for the output layer. Self.added parameter. QGIS processing parameter feature sync. Self.output self.tr output layer with a feature count. Process the algorithm. Define processing algorithm. Self parameters context feedback. Get the source input layer. Source equals self.parameter as source. Parameters, self.input and context. Raise the exception if the source layer is invalid. If the source is none, raise QGIS processing exception self.invalid source error. Parameter, self input. Create a new fields object and add the existing fields from the input layer. Fields equals source.fields. Added a new field for the feature count. Fields.append QGIS field feature count and key variant is integer. Get the sync output layer sync, comma, dist id equals self dot parameter as sync. Parameters self output context field source dot wkb type source dot source crs take projection from the source. Raise an exception if the sync output layer is invalid. If sync is none, raise QGIS processing exception self dot invalid sync error parameters self dot output. Then count the total number of features. Total features equals source dot feature count feedback dot push info. F string total features is total features underscore features. Calculate the total progress percentage. Total equal 100 divided by total features. If total features else O feature equals source dot get features. For current feature in enumerate features. If feedback is cancelled, break, create a new feature with the same geometry and attributes. New feature equal QGIS feature fields. New feature dot set geometry feature dot geometry and copy existing attributes and add the new feature count. New feature dot set attributes feature dot attributes plus total features. Add the feature to the sync dot add feature new feature comma QGIS feature sync dot fast insert. Update progress feedback dot set progress in each current multiplied by total. Then return self dot output dist id. For count features should be internal id with no spaces. Count features, the name should be user-friendly name in the toolbox. The name is like a unique receipt ID for QGIS. Display name in the level user see clarity here avoids confusion. Parameter strips. QGIS processing parameter feature source defines what the user can input, such as vector layers. QGIS processing.type vector any geometry restricts input to vector layer, points, lines, or polygons. Processing logic. Parameter as source converts the user's input into a readable data object, like opening a file. In the field management, fields equal attribute table columns. Here we copy existing fields and add a new integer column for our count. Feature iteration. Why a loop? We process each feature one by one to avoid overloading memory. Set attributes copies all data. The plus adds new count. Think of this as updating a spreadsheet row. Why feedback matters? Feedback provides user updates and allows cancellation. Without this, QGIS might freeze during large tasks. Let's copy the script and paste it inside processing script editor. Ctrl O, then Ctrl V. We save it with the meaningful name, such as script or count features. For now, we can run it